Sample problems. Very similar to your homework problems. So we just have to pay attention to the instructions and make sense of it. What is the logarithm? Same thing if they ask you what's the inverse form of boom. Remember, this is an exponential equation. So they're telling you find the logarithmic form or the inverse form. These two things mean the same thing. So it's like, okay, that means I need a log. So it'd be log, the base is 3, right there. My answer is 81, it goes right there. My power goes right here. So I just said 3 to the 4th equals 81. Pretty simple if you kind of know the foundations of logarithms. Now I'm going to mess with you a little bit. And I'm very linear minded, so I like things a certain way. My brain kind of shuts down if it's not like presented the same way every time. And they're going to stretch you a little bit. So then they say, okay, do the same thing for this. Well, the way that's written, I'm kind of thrown off. So I might literally rewrite it so I can see base 7. So log, there's my base. And if I want to, stick with the program, because you're supposed to go this way. I didn't in the previous one. But then I put my power right here, normal size. Base is small, so maybe I made that too big. It's supposed to be super small. And then I put my answer right there. That's the inverse of this exponential equation. Let's go on to the next one. So the next one, now they're messing with us even more, because now they're not giving us numbers, so you can't really say, yeah, that's true. You just have to follow the rules. First thing I'm going to do is spin it around so I can see, that's my base. So log, make that little base super small. And I'm going to put my equals in, because I know my exponent belongs over here, which is x. And my answer is right there, which is y. This is my answer for this problem written in inverse form or logarithmic form. I think you guys are getting it. Grand finale, sample problems. I'm going to let you get after your homework. This says find the values or evaluate. What does that mean? It means find the missing part. Okay, well, let's dive in. There's the missing part. 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 So if there's only 2 of the 3 parts of a logarithm, you've got to fill in the missing part and find out what x is. How do you do that? Start here, go here, change it into an exponential equation. So my base becomes big, my exponent becomes small, 81. You do this one in your head. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So that took 4 of them. So I know x is 4. So this would equal 4, because 3 to the 4th equals 81. Let's move on to this one. You'll see the repetitiveness of this, I hope. Base, exponent, answer. Climb the ladder. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2, 5 of them, 32. So this has to be 5, which means this whole thing equals 5. That would be my answer. So this one, this has a little trick. So I hope you didn't turn it off. Base, exponent. Base, exponent, answer? This takes us back to a problem where it's like, hey, when I raise anything to what power, I get 0. Is that even possible? 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th, 3 to the negative 1 would be 1/3. That's still not 0. Guess what? Not possible. And how about this one? Throw this one in for free. What does this equal? X base exponent answer. Something 3 to what power is 1? Remember, anything to the 0 power is 1. That's a tricky one. So is that one. All right, let's move on. This one just looks weird. Might be overwhelmed by the amount of information. You might overthink it. Stick with the program. Base exponent equals my answer. And I think that's the hardest looking one. But all of a sudden it's super easy. Common basis, happy places. So what do I get? X is 8. Go to this one. Base exponent answer. Base exponent answer. Do you think it's possible to raise a positive number to some power and get a negative? So think about it. There's just no way. 7 to the 0 power is 1. Second power, 49. Third power, 343. Some of you might say, well, maybe this is negative. Well, remember, if this is a negative 1 power, all that means is 1/7. It's still positive, so there's no way I can raise 7 to a power and get a negative value. So, we got one more to show you. I said 1, but you can tell I'm a math junkie. I don't think you'll be perfectly ready unless I show you 2 more. So, sorry. All right, getting wonky looking. So there's one of these in the pre-lesson. I just wanted to cement your understanding with these types. So evaluate. What does that mean? Well, there's a missing piece. Don't change the rules. Base gets big. That's my power. That gets small. And then my answer just kind of stays. And I'm looking at that like, do you remember that little poem? Common basis, happy places, 99.9% of the time. You're going to take the big number and you're going to make it some form of that small number, so you're going to change the base. So 27 can be written as 3 cubed. Now what's the trick? There's an invisible 1 there, so I'm going to bring this whole thing up. That's 3 to the negative 1 power now. That x is just there, equals 3 cubed. Remember, power to power we multiply, so 3 to the negative 1x equals 3 cubed. Essentially, these drop out because they're the same. I just know that this equals this. So negative 1x equals 3. And we'll multiply by negative 1, multiply by negative 1, x is negative 3. That's what this equals. It equals negative 3. Similar problem, just a little different. Equals x. Start here, go here, go here. What do you mean? Base, exponent, answer. Well, okay, if these are handmade to work out, which they are right now, I'm going to change that 81 to base 3. So 3 to the 4th is 81. You can check it on your calculator if you don't believe me. But I got 3 to the x equals, I want 3 to some power, and then I can say, x equals whatever's in that box. If I bring this positive exponent up, it's going to make that 4 negative, and then I go, x equals negative 4. Okay, that's it. Go get that homework.